Hello students, Mix There here. Welcome to your ninth and final must-do lesson of Unit 2. We're looking at Lesson 2.9, Representing Context with Equations. Here's your journal page set up. Our learning targets today are I can explain what the solution of an equation means for a situation, and I can write and solve equations to represent situations that involve rational numbers. And we've been working a lot with talking about our operations and our inverses, but I just wanted to do one more review of these one-step algebraic equations with our inverse operations. So in this first example, we're going to look at negative 3 plus x equals 27.5. So the operation that we are dealing with is addition, which means we will be working with our additive inverse. And the goal of that additive inverse is to make a zero. Make a zero. Okay, so in order to make a zero with negative 3, we need to add its opposite. The additive inverse of negative 3 is positive 3. So we're going to add 3 to both sides of this equation. That way we're keeping it true and in balance. Negative 3 plus 3 is 0. That is the definition of the additive inverse. So all we have left, 0 plus x equals 27, 28, 29, 30, 30.5. And if we ever have 0 being added to something, we can just get rid of that 0, or we imagine it's not even there. So what this actually just means is x, or our unknown value, equals 30.5. Let's look at this second example. Here we're looking at negative 3 times x. Remember, if you have a number outside that variable, that is multiplication. Negative 3 times x equals negative 27. So our operation is multiplication, which means we will be using the multiplicative inverse. Again, whenever we're using that multiplicative inverse, the goal is to make a 1. We're trying to figure out what 1x equals if negative 3 times x equals negative 27. So let's recall here that the multiplicative inverse of negative 3, which could be represented as negative 3 over 1, is negative 1 over 3. And we would have to do the same thing to the other side. So this would look like taking that negative 27, putting that over 1, times negative 1/3. So if we go ahead and we calculate all that out, and again, I threw my x in there just to be like, let's remember that those numbers are being applied to that x. We come out with negative 3 times 1 is 3 over 3. Negative 27 times negative 1 is positive 27 over 3. So we come up with, I've got to drop that x down still. We come up with 1x is equal to 9. So you have probably seen this in other ways. This is the long way of doing it, understanding that multiplicative inverse. We can also remember, I'm going to go ahead and erase and just show this in a little bit of an easier way, that all of that work we just did is to also show that multiplying by a fraction is the same thing as dividing. So we could also say that in order to perform the multiplicative inverse here and make that 1, we could just divide each side by negative 3. And that comes up with the exact same thing, where we end up with 1x equals positive 9. Multiplying by negative 1/3 and dividing by negative 3 gets us that same result. All right, you're going to be working in your journal problems on this whole segment called warmer or colder than before, where you are given some word statements and you are asked to choose from a bank of equations which equations best represent your situation. So I'm going to do an example right here. It says between 6 a.m. and noon, the temperature rose 12 degrees Fahrenheit. So I'm going to go ahead and highlight that to 4 degrees Fahrenheit. So there's some really key words in there. One is rose. That means it's going up. And this word to means that was the end results. So by doing this step where I just highlighted these words, these little clues for us, that's going to help us figure out what our variable is going to be. Okay, what is that missing piece of information? So we know what the change is. The change is that rise of 12, and we know what our end is. Our end is 4. So that means our unknown, or our variable, in this case they're using the variable v, our unknown is v, and that's going to be the starting temp. That is the piece of this that we don't know. We don't know our starting temperature. So we're going to be looking for our starting temperature. We know it's rising 12 plus 12 is going to land us at 4. Let's go ahead and look through our bank and see if we have that equation. And we do. It's right there. But there's supposed to be 2 that works for this. So let's look through here and see what other situations represent a temperature that when it gets 12 degrees warmer becomes 4. And my clue here is I know that my equation needs to have an unknown, a positive 4, and then something in there that's representing a change of 12. So let's look through here. It's not going to be that one. It's not going to be that one. That one. Nope. 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 Let's check out this one. Let's see if that one makes sense. I see a 4 and I see this change. So this story right here says that we have a temperature and it is equal to our current temperature of 4 plus negative 12. Let's go ahead and solve this using our one step and see if that could be the one. I do think it is, but we need to make sure it makes sense for our situation. Okay, so using our inverse operations here, we would say that, well, we're going to go ahead and add a negative 12 to make a 0 there. So there's that negative 12 right there, which just turns into v plus 0 equals, and we could call this 4 plus negative 12, which is just v equals 4 plus negative 12. And sure enough, that is right there. So we would say that v equals 4 plus negative 12 is equivalent to v plus 12 equals 4. You're going to be doing this process on your own with several situations. Anytime we're writing equations, even if it's not attached to a specific story problem, our equations are still always going to be telling a story. But when we are specifically writing equations to represent a situation, we need to be thinking about what our variable represents. Our variable is always going to be the unknown element. So in that last example, our variable was the starting temperature. We have seen our variables represented as how things are changing. We've seen it represented as an unknown velocity or an unknown time or an unknown end position. The variable is always the piece that we are looking to solve. And so once we have that variable defined, what do we do to actually solve our equations? Well, what we're going to do is we're going to use our known information to set up an equation and then use our inverse operations to undo it. And for the sake of the next few problems that you'll be working on in this lesson, our structure will always be something along the lines of P plus X equals Q where x is our unknown. Or p times x equals q, where x is our unknown. So we're looking at situations where we have positive or negative values being added to an unknown thing to give us a result, or positive or negative values being multiplied to an unknown thing to give us our result. Okay, so in your journal problems today, you will also be given a bank of problems and being asked to choose one, and you can either do this by yourself or with a small group, and you'll be creating a visual display of a situation, and each display has to include an equation that you write to represent the situation. You need to be thinking about the meaning of your variable, thinking about what each term in the equation represents. Are you adding? Are you subtracting? Or I should say, are you adding negatives? Are you multiplying integers? Are you multiplying fractions? And then you're also thinking about how the operations in the equation represent the relationships in the story, meaning what is going on between these numbers. You'll be talking about how you use your inverses, your additive inverse, your multiplicative inverse to solve for your unknown quantity, and you will also be solving your equation. I'm going to go through this step with just an example problem. So we have this problem, and Lydia, thank you for letting me use you, but Lydia earns $10 per hour making felt sculptures of people's pets. She's saving up to buy the JPhone 500, which costs $999. And we're being asked how many hours will Lydia have to work to save enough money for her new phone. So I'm going to go ahead and pause this and let you kind of jot down some thoughts about all of these bullet points. How would you start to make sense of this? All right, so I went ahead and just picked out the pieces of countable data. We know that she is earning $10 per hour. We know that the result, what she wants, is that $999. And we know our unknown is the number of hours she's going to have to work. With this information, I can write an equation. I'm going to say, well, my variable, x, is the number of hours she has to work. I know that she is earning $10 per hour, so we need to know, well, if we multiply 10 by that number of hours, it needs to equal the amount of money she wants. She wants $999. And now we can use our inverse operations here, set up our little t-chart. So the inverse operation of multiplying by 10 would be multiplying by 1/10, which turns into division. So I'm just going to go ahead and say, well, to make that 1x, I'm going to divide this by 10 and divide this by 10. Again, that's the same thing as multiplying each side by 1/10. Okay. So 10 divided by 10, or 10 times 1/10, equals our 1x, and 999 divided by 10, or 999 times 1/10, is going to equal 9.99. Now, what does this mean? What that means is that she's going to have to work 9.99 hours to buy the phone. So if I were creating my visual display here, I would also be talking, so I already talked about the equation, the meaning of the variable, what each term represents. I did that right here. I said that 10, I could say multiplying, that 10 represents $10 per hour being earned. I could say that my $99 represents the end result, or the amount she needs, and that my variable represents the number of hours. I verbally talked about my inverses. You might want to write a sentence and the solution to my equation. You could be a little more verbose there. I could write something a little more detailed, like Lydia needs to work 9.99 hours to afford the new J-Phone 500. All right, so go ahead and grab those journal problems and get to work, and good luck and congratulations on finishing all of your must-dos.